Robert's Shed Log, 22nd of March 2020. Hello, I'm Robert and welcome to my shed. I've been learning about woodwork and I'm going to share that information with you as I go. The point of these videos, this particular series, is I'm building a workbench. This is going very, very slowly. But it's going, and I'll share with you what I've learnt, what changes I've made to the design, and so on as I go. This is a whole channel of these videos. They're about 10 minutes, 10-15 minutes long each. Help yourself. So, this is my workbench, which you can just not see because it's off screen. Maybe do a cutscene, you'll sort that out a bit better. I've made a couple of changes to the design since last time, mainly because I've learnt more about joints, particularly peg-through mortise and tenon joints, which is what I'm using. A lot of people call these tusk joints because the peg fits through the hole like a tusk, but tusk joint does have another meaning, which is a kind of joint used in old-fashioned structural floorboards, which I'm not using. So I've been calling them peg-through mortise and tenon joints. And I think that's right, but I'm contradicted by a lot of the internet. So I've made one big change, which is to replace the front left leg with this one. This is cut from what I was calling board B, which is a reasonably good board. It's still, as you can see, possibly there, fairly close to the heartwood. I don't know if you can see that. Yeah, you can just about see the grain now. It's coming to the heartwood just here. And the idea is that this will sit there. And the reason I did that is to position the horizontal stretchers. So I have stretchers running front to back on the sides and left to right on the front and back. And over there, you'll see a lot of numbers. Those were basically my working out where the knots were in all pieces of wood and trying to find somewhere that I could put the wood without causing problems with knots. And I figured I could do it if I just replaced one leg, so I've replaced that leg. The reason I don't cut through knots is because if you try and hammer and chisel through a knot, you can either knock the whole knot out in one go and your joint's ruined, or it can just knock your chisel off course and again your joint is pretty much ruined. As you can see, I've made this. This is most of yesterday's work. This is a hipped mortise joint. So the idea of this is the side piece will go through here. It will extend out. The tenon will extend out beyond this. And there'll be a peg here. This is a lot. Normally, if you're cutting a mortise and tenon, you want a third of the width of whatever you're cutting to be the mortise, the hole. This is a bit more than a third. That's because it's going to be a peg-through joint, and peg-through joints are stronger, but you need more width than the tenon to cut the peg. I have to say this is freaking me out a little bit because there's not a lot of width left there and the entire weight of the bench is going to be on the top. I also made a slight mistake, I don't know if you can see it, in terms of the cutting of the end piece. I used the miter saw as a chop saw to cut the piece to length, and being a chop saw, being a miter saw, it cut it at a 3-degree angle instead of straight. I didn't have it quite set up properly. So I've lost a little bit of length on the top. So I might have to lower everything by a few millimetres, maybe a quarter of an inch, just to size it. But that's okay. I deliberately made it slightly over that wall so I could cut it down if I needed to. I want to get the height right. Yeah, so I've got a little bit more tidying up to do on this. I've got still a bit of rough wood on the inside that needs to be hammer and chiseled out. That's all hammer and chisel work took most of the day to do it. This bit was slots to the tenon saw and then chisel from the sides to get the block out, which is a lot easier. So I guess you call it an open-faced hip. Normally the hip would be not the full width, but I just figured I couldn't chisel 6 inches of 150 millimetres of wood. Now, the way it's worked out, yes, I've been working in inches to do the joints, but I've been working in millimeters to position the joints, and it's interesting. The reason for doing that is this stuff over here. I found a website online which I'll post a link to, which basically gives you advice on working out on how to do the dimensions for a peg through mortise and tenon, which it calls a tusk joint. It's not, but from the description, it's not talking about tusk joints, it's talking about peg through mortise and tenon. And basically, it turned out that you wanted dimension T, everything's done in terms of T, and T was half the width of your material, or a third of the length of your material. This is 2 by 6, so T is not an inch. So just made all the numbers made a lot more sense. Plus, doing joints, you're doing a lot of halving, because you want 1¼ inches centered on 2 inches, and that means you inch and a half, and then halve that, and work it up on the side, and so on and so on. So we go. Yeah, another thing that I looked at was I was originally going to have the structures going in. So if that's a leg, I was originally going to have the stretchers going in like this. And that would have meant there was a 2 by 2 inch square where the two met, which really wasn't enough space to put a joint in. So I've changed it so that the stretchers go in this way up. This also means that the side stretchers will be going in this way up, which is a fairly standard way of doing a peg through mortise and tenon. That will work pretty okay. It's just a little bit oversized, so everything takes a bit longer. This week I'm going to detail on saws. So we're going to start with this, the pruning saw. See the holes in the blade. This is for live wood. It's for cutting branches off trees. So these holes allow the sappy wood that would normally cling to the blade, just gives it a channel to fall into as the saw is moving, so it gets out of the way. You have these smaller teeth which are fairly sharp. They're angled either way, either side of the blade, to give it a little bit more cut. It's also very thin, so that the channel you cut is very thin. It makes it very neat and tidy, which gives it less chance of rough surfaces that could cause infection on the tree. This is a pruning saw. For dead wood, the primary go-to saw for most people would be one of these. This is a rip saw. This is about a first fix rip saw. You see the 7 teeth per inch. Fairly big teeth, reasonably thin blade. And this works by getting in between the fibres of the wood, splitting them apart, and cutting anything that's left in the middle to create a channel, and the channel guides the saw through. Lots I could say about this. The shiny surface allows you to check if the thing is lined up by the reflection. Finger hole to keep your hand going in a straight line. And lovely 90-degree angle for measuring out. You start by cutting like this, and you just keep on that angle. Go across the grain, however, they don't work very well because they tend to get between the fibres. And going across the grain, there are no fibres to get between. So you'll notice I tend to stroke the back of the blades of a saw when I pick them up. It's a habit I get into to avoid sawdust. So I'm just going to clog up between the teeth. Always pull away from the blade. You can collect on the back of the blades, always stroke away from the teeth. The tenon saw has much shorter holes, much shorter teeth, and is also relatively thin, but also has a thick strengthening piece on the back to keep the blade straight even when the wood tries to twist it off, twist it to the side. This works, this pulls as a rip saw does on the back stroke, so as you're pulling, push and then cut. This works by ripping apart the fibres. It's much more flared teeth, rips the fibres apart and just cuts. Makes reasonable progress. It's not as fast as a rip saw, but it's not bad either. Sometimes you have the board, and you want to cut a hole in the board. And for that, use a board saw. Board saw has a sharp point for starting off the cut, and it has giant teeth flared either side. It's very thick, so it's got a lot of cutting action. It's not designed to do nice, neat cuts. It's just there to get a hole in a board that you can tidy up later, without having to cut in from the side. Which, if you've got a piece of 8x4, 8 foot by 4 foot, or 2 meters by 1 meter piece of wood, really easy to be able to get into the side and start cutting. If you want to round a hole, you can use a hole saw bit. A hole saw bit is an ordinary drill bit with a jig on top of it. This jig holds a saw in a bent piece of sprung steel with fairly small teeth, all in the same direction, some in, some out, but all pointing the same way, or no clever angles or anything. It's designed to go onto a drill, so it spins around in a cutting action, cutting a round hole. You can get these up to fairly big sizes. That's great if you want to get a cable or a pipe through a piece of board. The other woodworking saw I've got to show you is the coping saw. There's a similar saw to this called a fret saw, which is a bit bigger and has a thicker blade, and that's for cutting straight lines, but this is for cutting round cutouts. The coping saw and the fret saw are both designed for cutouts, that is, cutting the middle of a piece of wood, not the edges. As you can see, it's a really thin blade, tiny holes. You do a full stroke and you've cut about 1 millimeter of wood, if that. Probably more, half or even 1/3 of a millimeter with each stroke. So it's a really slow progress, but you can get a lot of precision and a lot of fine curve detail. But you really can't go to a straight line because there is no length to the blade. There's nothing to make a channel to cut through. If you want to cut metal work, you can use a hacksaw. Hacksaws have really thick blades designed to make a channel, and tiny teeth designed to be really sharp. And they are flared, so there's one on each side. This is actually quite an old blade, as you can see by the rust on the fact that it's missing some teeth. But it does still work. Hacksaw will cut through any kind of metal. You can hold the end and it's a two-handed saw, but it's really designed for one hand. It cuts straight lines through metal. These are reasonably thin trail, but if you want really precise work, if you've got a bit of metal protruding out of a piece of wood and you want to cut it smooth, then you need the junior hacksaw. Now, I said previously in this blog that the junior hacksaw will cut through wood fine, and it does. But look at that. Okay, the camera isn't focusing, but you can, I think, see enough to know that the teeth are virtually non-existent. The coping saw has bigger teeth. This is really for slow progress on very fine work. It's a very thin blade. It's a very thin saw. You can get right up to the thing you're cutting. It's a single piece of metal. It bends easily. This is one of the cheaper saws you can buy. It's really only useful for small, intricate work, and it should really be only used for metal work. You can use it for wood. I've done so many times. Doesn't really blunt on the blade at all, but it's not recommended. At worst, you'll wreck the blade and have to replace it, but blades are really cheap. But for wood, you should really be using at most a tenon saw, and if it's too fine for a tenon saw, a hammer and chisel will get you through. So, that was a quick round for saws. That's it for Shed Log this week. Ta-ta! Still the same shaving injury as last week. It still hasn't healed properly. And this one is from tightening a bolt, of all things. Isn't the human body's ability to heal itself wonderful? keep that in mind in the current climate.